Hi guys, tonight we're diving into one of the most mind-bending implications of quantum mechanics. What if every choice you make, no matter how small, creates an entirely new universe? What if hitting the snooze button this morning literally split reality in two, creating parallel worlds that diverge with each decision? If you enjoy these reality-shattering sleep stories that explore the deepest mysteries of quantum physics, hit that like button and subscribe for more, and drop a comment letting me know what time it is where you are and where you're listening from. It's always fascinating to see where all of you are listening from. All right, let's begin. The morning alarm pierces through Sarah's dream at precisely 7:15, and in that singular moment of awakening, something extraordinary unfolds across the infinite expanse of reality. As her consciousness emerges from sleep, she faces her first decision of the day: hit the snooze button for 9 more minutes of rest, or rise immediately and begin her morning routine. What she doesn't realize, what none of us realize, is that this seemingly trivial choice is about to split the universe in two, creating parallel realities that will diverge and multiply with each subsequent decision she makes throughout her day. This is the profound implication of the many worlds interpretation of quantum mechanics, a theory that suggests every quantum measurement, every moment of uncertainty, every choice we make causes the universe to branch into multiple parallel realities. If this interpretation proves correct, then right now, as you listen to these words, countless versions of yourself exist across an infinite multiverse, each living out the consequences of every possible decision you've ever made or could have made. The concept originated in 1957, when physicist Hugh Everett III proposed his revolutionary interpretation of quantum mechanics as a graduate student at Princeton University. Everett's work challenged the conventional Copenhagen interpretation, which suggested that quantum particles exist in a state of superposition until observed, at which point the wave function collapses into a single reality. Instead, Everett proposed that the wave function never collapses. Every possible outcome of every quantum event occurs simultaneously in separate, equally real universes. To understand the staggering implications of this theory, consider the quantum events occurring within your brain right now. Every second, approximately 100 billion neurons fire across synaptic gaps measuring just 20 to 40 nanometers wide. Each neural transmission involves quantum mechanical processes, with neurotransmitter molecules existing in quantum superposition until they interact with receptor sites. If every quantum event spawns new universes, then the human brain alone generates trillions upon trillions of parallel realities every single second. The mathematics behind this concept are as elegant as they are mind-bending. The Schrödinger equation, which governs quantum mechanical systems, describes how wave functions evolve over time. In Everett's interpretation, this equation never requires collapse terms or special measurement postulates. The wave function of the entire universe continues to evolve unitarily, encompassing all possible states simultaneously. What we perceive as the collapse of the wave function is merely our consciousness experiencing one branch of this ever-expanding tree of realities. But let's return to Sarah and her alarm clock to explore how this cosmic branching might unfold in practical terms. In Universe A, Sarah hits the snooze button. The additional 9 minutes of sleep causes a cascade of consequences. She arrives at work 7 minutes late, missing the morning briefing where her colleague announces an unexpected project deadline. Because she missed this crucial information, she submits her quarterly report a day late, which ultimately influences her annual performance review and affects whether she receives the promotion that would have led her to meet her future spouse at a company conference in Denver. Meanwhile, in Universe B, Sarah immediately rises at 7:15. She arrives at work 12 minutes early, attending the full morning briefing and learning about the accelerated deadline. Her timely report submission impresses her supervisor, contributing to the excellent performance review that secures her promotion. At the Denver conference, she strikes up a conversation with a software engineer from Portland during the lunch break, leading to a relationship that produces 2 children and a life path radically different from her Universe A counterpart. These divergences multiply exponentially with each subsequent choice. When Universe B Sarah decides to order coffee instead of tea at the conference, this splits into Universe B1 and Universe B2. Her choice to take the elevator rather than the stairs creates Universe B1A and Universe B1B. Within just 24 hours, the original morning decision has branched into billions of parallel realities, each representing a unique combination of choices and their consequences. The scale of this branching becomes truly incomprehensible when we consider that every person on Earth makes an estimated 35,000 decisions per day, ranging from significant life choices to subconscious micro-decisions about where to direct our attention. With a global population exceeding 7.9 billion people, we're looking at approximately 276 billion individual decisions occurring daily across humanity. If each decision spawns multiple universe branches, we're witnessing the creation of countless quintillions of new realities every single day. But the implications extend far beyond human choices. Every quantum interaction in the natural world potentially creates new universes. Consider a single leaf falling from an oak tree in Central Park. As the leaf tumbles through the air, countless quantum interactions determine its exact trajectory. Air molecules colliding with its surface, photons striking from different angles, gravitational influences from nearby masses. Each quantum event represents a branching point, creating universes where the leaf lands on slightly different spots on the ground, perhaps 1 centimeter to the left in one universe, 2 centimeters to the right in another. The leaf example illustrates how quantum branching occurs throughout the natural world, independent of conscious observers. In the Amazon rainforest, approximately 400 billion trees interact with their environment through trillions of quantum processes every second. Photosynthesis alone involves quantum coherence effects, where chlorophyll molecules exist in superposition states while harvesting light energy. Each photosynthetic event potentially branches the universe, creating parallel realities where energy conversion occurs with infinitesimal differences that could accumulate into significant environmental variations over time. These environmental variations cascade through ecosystems in profound ways. In one universe, a quantum fluctuation might cause a particular pollinator to visit a specific flower 3 seconds earlier than in another universe. This seemingly insignificant timing difference could affect which plants reproduce successfully, altering the genetic makeup of future plant generations. Over decades, these accumulated quantum differences could reshape entire ecosystems, creating universes where the Amazon rainforest has different species compositions, varying carbon absorption rates, and distinct climate influences on global weather patterns. The economic implications of infinite branching universes are staggering. Consider the New York Stock Exchange, where approximately 4 billion shares trade daily with a total value exceeding $160 billion. Every trade represents a human decision influenced by countless factors, many of which involve quantum mechanical processes in the traders' brains. If every quantum event in every trader's decision-making process creates new universes, then we exist within a multiverse containing versions of Earth where market outcomes differ dramatically. In some universes, the technology stock that Sarah's Universe B husband invested in might have appreciated by 3,000% due to a slightly different sequence of quantum events influencing the company's research breakthroughs. In others, the same investment might have lost 90% of its value because quantum fluctuations in a different researcher's brain led them to pursue an alternative approach that failed. These variations ripple through the global economy, creating universes where different nations lead in technological innovation, where energy markets develop along entirely different trajectories, and where economic inequality follows radically different patterns. The technological implications become even more fascinating when we consider artificial intelligence and machine learning systems. Modern AI algorithms make thousands of computational decisions per second, often involving quantum mechanical processes within semiconductor devices. If quantum events in computer processors create parallel universes, then we inhabit a multiverse where AI development follows countless different paths. In some universes, quantum fluctuations in a critical machine learning algorithm might lead to artificial general intelligence being achieved 3 years earlier than in our current timeline. In others, those same fluctuations might cause crucial breakthroughs to be delayed by decades. These variations could fundamentally alter human civilization's trajectory, creating universes where humanity successfully addresses climate change through AI-assisted technologies, and others where technological development follows less favorable paths. The climate implications of quantum branching deserve special attention. Earth's climate system involves countless quantum mechanical processes, from molecular interactions in the atmosphere to quantum effects in cloud formation. Every quantum event potentially branches the universe, creating parallel realities with slightly different climate trajectories. Consider the quantum processes occurring within a single cumulus cloud forming over the Pacific Ocean. Water molecules exist in quantum superposition states as they transition between vapor and liquid phases. Each quantum transition potentially creates new universes where cloud formation occurs with infinitesimal differences. Over time, these microscopic variations could accumulate into significant weather pattern changes. In one universe, quantum differences in cloud formation might lead to a tropical storm developing 12 hours later than in another universe. This timing difference could cause the storm to encounter different atmospheric conditions, potentially strengthening it into a Category 5 hurricane instead of dissipating harmlessly over open ocean. The resulting landfall could cause billions of dollars in damage and displace hundreds of thousands of people, dramatically altering the socio-economic development of affected regions. These climate variations become particularly significant when we consider tipping points in Earth's climate system. Scientists have identified approximately 15 critical tipping points, including the collapse of the West Antarctic ice sheet, the shutdown of the Atlantic meridional overturning circulation, and the dieback of the Amazon rainforest. In our current universe, these tipping points might be reached at specific global temperature increases, perhaps 1.5 degrees Celsius for Arctic permafrost thaw, or 2 degrees for widespread coral reef die-offs. However, in parallel universes where quantum events have accumulated differently over decades, these tipping points might occur at slightly different temperatures or timelines. Some universes might feature more resilient climate systems due to favorable quantum accumulations, while others might face accelerated climate breakdown. The quantum branching theory suggests that across the multiverse, every possible climate outcome is playing out simultaneously, from futures where humanity successfully stabilizes the climate to catastrophic scenarios where multiple tipping points cascade into runaway warming. The biological implications of quantum universe branching touch on some of the most fundamental questions about life itself. DNA replication involves quantum mechanical processes, with enzymatic reactions operating at the molecular level where quantum effects become significant. Each time a cell divides, quantum uncertainties in molecular interactions could potentially branch the universe. Consider human reproduction and development. The fusion of sperm and egg involves countless quantum mechanical processes, from the initial penetration of the egg membrane to the complex cascade of genetic activation that follows. Each quantum event during fertilization and early embryonic development potentially creates new universes where genetic expression unfolds slightly differently. In some universes, quantum variations during neural development might enhance certain cognitive abilities while diminishing others. A child who becomes a brilliant mathematician in one universe might develop exceptional artistic abilities in another, simply due to quantum differences in early brain formation. These variations cascade through that individual's entire life trajectory, affecting their educational choices, career paths, relationships, and contributions to society. The implications extend to evolution itself. Random mutations which drive evolutionary change often result from quantum mechanical processes, such as cosmic ray interactions with DNA or quantum tunneling in chemical bonds. If every quantum event creates new universes, then evolution follows countless different paths across the multiverse. In some universes, the quantum event that led to the extinction of dinosaurs 66 million years ago might not have occurred, or might have occurred differently. Perhaps the asteroid struck Earth at a slightly different angle due to quantum variations in its trajectory, causing less severe environmental disruption. These universes might feature evolutionary paths where dinosaurs continue to evolve alongside mammals, potentially developing intelligence and creating civilizations radically different from our current human-dominated world. The philosophical implications of quantum universe branching challenge our fundamental understanding of identity, choice, and moral responsibility. If every possible version of ourselves exists across the multiverse, what does this mean for personal identity? Are we singular individuals making unique choices, or are we merely one branch of an infinite tree of possibilities, all equally real and valid? Consider the ethical dimensions of decision-making in a branching multiverse. If every possible choice you could make is actually made by some version of you in parallel universes, does moral responsibility lose its meaning? When faced with an ethical dilemma, you might choose the virtuous path in this universe while simultaneously choosing every possible alternative in other universes. This creates a paradox where perfect virtue and complete moral failure coexist within your multiverse identity. Some philosophers argue that this paradox dissolves when we recognize that moral responsibility operates within individual universe branches. The version of you in this universe bears responsibility for your choices here, regardless of what your parallel selves do elsewhere. Others suggest that multiverse existence actually enhances moral responsibility by demonstrating that every possible choice is realized somewhere, making the consequences of our decisions more, not less, significant. The concept of death becomes particularly complex in a branching multiverse. In quantum mechanics, the line between life and death involves quantum processes at the cellular and molecular level. Each quantum event that could lead to biological failure potentially branches the universe, creating realities where death occurs and others where life continues. This leads to the disturbing yet fascinating possibility that from your subjective perspective, you might be functionally immortal. In every situation where death is possible, quantum branching creates universes where you survive and others where you don't. Your consciousness only continues in the survival branches, meaning you would subjectively experience an infinite sequence of increasingly unlikely survival scenarios. Imagine a traffic accident where quantum variations in timing create multiple universe branches. In most branches, you're severely injured or killed, but in some small percentage of branches, quantum fluctuations cause you to look up at just the right moment, notice the oncoming vehicle, and step aside. Your consciousness continues only in these survival branches, potentially leading to a subjective experience of miraculous escapes from increasingly improbable death scenarios. The technological implications of accessing or communicating across parallel universes have captured the imagination of physicists and science fiction writers alike. If parallel universes exist, could we potentially observe or interact with them? Some theoretical physicists have proposed that quantum tunneling effects might allow information to leak between closely related universe branches, though such effects would likely be undetectably small. More speculatively, some researchers have suggested that advanced civilizations might develop technologies to harness quantum branching for practical purposes. Quantum computers already exploit superposition and entanglement effects that might represent limited access to parallel universe resources. Perhaps sufficiently advanced quantum computers could perform calculations by accessing the computational power of parallel versions of themselves across the multiverse. The possibility of multiverse communication raises profound questions about information and knowledge. If every possible scientific discovery is made in some parallel universe, do we already have access to all possible knowledge through quantum mechanical connections? Some interpretations of quantum mechanics suggest that human intuition and creativity might partially result from consciousness accessing information from parallel versions of ourselves who have made different discoveries or followed different intellectual paths. The historical implications of quantum branching suggest that every possible version of human history exists simultaneously across the multiverse. In some universes, Alexander the Great lived to age 80 and established a permanent Hellenistic empire spanning 3 continents. In others, the Library of Alexandria was never destroyed, leading to scientific advancements centuries ahead of our current timeline. Every historical figure who died young continues living full lives in parallel universes where different quantum events prevented their premature deaths. World War II alone represents countless universe branches based on quantum events affecting crucial moments. In some universes, quantum variations in weather patterns might have prevented the D-Day invasion from succeeding, dramatically altering the war's outcome. In others, quantum differences in atomic physics research might have led to nuclear weapons being developed earlier or later, completely changing the balance of global power. These historical variations cascade through subsequent decades in profound ways. Universes where the Cold War never occurred might feature radically different technological development paths, with space exploration advancing more rapidly due to international cooperation rather than competition. Others where nuclear warfare actually occurred might show how human civilization can recover from catastrophic destruction, or demonstrate the ultimate consequences of nuclear proliferation. The scientific implications of quantum branching extend to our understanding of fundamental physical laws themselves. If every possible universe exists, then we inhabit a multiverse containing realities where the fundamental constants of physics have different values. The fine structure constant, which determines the strength of electromagnetic interactions, has a value of approximately 1/137 in our universe. But across the multiverse, this constant might have slightly different values, leading to universes where atoms cannot form stably, where nuclear fusion occurs more easily, or where electromagnetic forces dominate over gravity at larger scales. These variations in fundamental constants create universes with radically different physical properties. In some universes, stars might burn through their nuclear fuel in thousands rather than billions of years, creating rapidly evolving cosmic environments. In others, gravity might be weak enough that planets cannot retain atmospheres, preventing the development of Earth-like worlds capable of supporting complex chemistry and biology. The anthropic principle suggests that we can only observe a universe capable of supporting conscious observers like ourselves, which might explain why the physical constants in our universe have the precise values necessary for complexity and life. But across the infinite multiverse, every possible combination of physical laws plays out, creating a vast landscape of realities ranging from universes teeming with exotic forms of life to sterile voids where no complexity can emerge. The quantum measurement problem, which motivated Everett's original many worlds interpretation, takes on new significance when considered across this vast multiverse. In the conventional Copenhagen interpretation, conscious observation somehow causes quantum wave function collapse, creating a special role for consciousness in physical reality. But if consciousness doesn't cause collapse, and instead, all measurement outcomes occur in parallel universes, then what determines which branch our consciousness experiences? Some interpretations suggest that consciousness naturally flows along all universe branches simultaneously, but each branch contains the illusion of singular experience. Others propose that consciousness has a preferred measure, experiencing more probable quantum outcomes more frequently than improbable ones. Still others argue that consciousness itself might be quantum mechanical in nature, with subjective experience representing a quantum information processing system that naturally branches with the underlying physical reality. The implications for artificial consciousness become particularly intriguing in this context. If we successfully create artificial general intelligence in machines, would these artificial minds also experience quantum branching? Would a conscious AI system subjectively experience one universe branch while simultaneously existing in all parallel branches? These questions touch on fundamental issues about the nature of consciousness, subjective experience, and the relationship between mind and physical reality. As we contemplate the infinite branching of universes from every quantum choice and chance event, we begin to grasp the truly staggering nature of existence itself. Every decision you've ever made, from choosing what to have for breakfast to selecting your career path, has spawned countless parallel realities where alternative versions of yourself explore different possibilities. Every person you've ever met exists in universes where your relationship developed differently, where conversations took alternative directions, where entirely different life stories unfolded. The universe you're experiencing right now, where you're listening to these words at this particular moment, represents just one branch of an infinite tree of possibilities. Parallel versions of yourself might be listening to different podcasts, reading books instead of listening to audio content, or pursuing completely different activities based on the accumulated quantum differences that have shaped their universe branch. This perspective transforms our understanding of regret, possibility, and human potential. The choices you didn't make, the paths you didn't follow, the relationships you didn't pursue, all exist in parallel universes where alternative versions of yourself explored those possibilities. In some sense, you are living every possible life simultaneously across the multiverse, experiencing every choice, every outcome, every conceivable variation of your existence. The branching continues right now as quantum events unfold in your brain while processing these ideas. Your thoughts about the multiverse theory might inspire you to explore quantum physics more deeply in some universe branches, while leading you to reject the concept entirely in others. Each quantum fluctuation in your neural networks potentially creates new universes where your intellectual journey follows different paths. Perhaps most remarkably, the act of contemplating parallel universes might itself create universe branches where this contemplation leads to different insights, different emotional responses, different life changes. In some universes, learning about quantum branching might inspire you to make more deliberate choices, knowing that every decision spawns new realities. In others, the concept might lead to a sense of nihilistic freedom, believing that since all possibilities occur anyway, individual choices lose their significance. But maybe the most profound implication is that in pondering these infinite parallel realities, we glimpse something extraordinary about the nature of existence itself. We exist within a cosmos so vast and creative that every conceivable possibility finds expression somewhere in the multiverse. Every dream, every fear, every hope, every tragedy, and every triumph plays out across infinite realities, creating a tapestry of existence richer and more complex than any single universe could contain. The quantum multiverse suggests that reality is not a single story with a definitive plot, but rather an infinite library containing every possible story that could ever be told. Your life represents just one volume in this cosmic library, sitting alongside countless variations where your story unfolds differently, where different choices lead to different adventures, where the fundamental nature of your journey through existence follows radically different paths while still being authentically, recognizably you. As you continue through your day, making the countless decisions, both large and small, that shape your experience, remember that each choice sends ripples across the fabric of reality itself, creating new universes, new possibilities, new versions of yourself exploring the infinite landscape of what it means to exist. In this view, we're not merely observers of reality, but active participants in the creation of infinite worlds, each decision a godlike act that brings new universes into being and shapes the eternal, ever-expanding story of existence itself.